Hello everybody, am I audible to you guys? Yeah, please tell me that I'm audible to you or not so that we can start our class. Hello everybody, am I audible to you guys? I think I'm audible to you properly. There is no problem at my side. But yeah, if you have any problem, if you face any issue, any technical issue, then you can tell me guys. Yeah, good morning Mohammed. Good morning Reddy. Okay guys, so very good morning to all of you. Very good morning to all of you. I hope that you are doing good guys and your preparation is going very well, right? Okay, so let's start the class guys. So as you know that we are studying the instrumentation and process control. It's your lecture number 8. Okay, so it's lecture number 8. Let's repeat the previous content guys. In the last class we have discussed about the transfer function of the first order system. As I told you earlier that this is the very important point. This is a very important expression that we have. We will use this transfer function in throughout the IPC guys, right? Because there is a lot of discussion about the first order system and you will get for sure 2 marks question related to the first order system. Okay, so transfer function is nothing but it is the Laplace transform of deviation variable of output divided by Laplace transform of deviation variable of the input, right? Related to this definition, I did not remember the year, but yeah, you'll find a gate PYQ based on this definition directly. So transfer function is nothing but it is basically build the relationship between input and output, so that for a particular change in input, how my output will change, I can tell, right? So for that purpose, this transfer function will help me. Now we were discussing the process dynamics. So we have discussed the process means the first order system. Now we have to you can say define the process dynamics, means the first order system, that for the particular first order system how input and output basically related to each other, right? So in this process dynamics, first of all we will see the response for the step input. Means if the step input disturbed my first order system, then how my output behave, how I will get my output guys, right? It is clear to you. Just remember this expression, y is divided by x is equal to gs. That's it, nothing else. If you are aware about it, then you can calculate everything. Also, where the response in the time domain is important for me. Okay. Yeah. So doing all the mathematics, what I'm getting, I'll get yt is equal to akp into 1 minus e raised to power e minus t divided by tau p. This is the response for the step input, guys. Am I clear with this? Yes or no? Am I clear with this? Yes or no? Please tell me. That is clear to you guys? Right? So remember this response. This will help you to calculate any term related to the first order system. Okay. For the unit step input, the mathematics is very simple. You have to put a equal to 1. A is basically magnitude of the disturbance, and as we know that for the unit step input, my a will be 1. So this expression will be converted into the kp into 1 minus e raised to power minus t divided by tau p, guys. Okay. Now let's try to build the graph of it. So yt is equal to kp into 1 e raised to power t divided by tau p. Okay. So if I'll put the graph, if I'll draw the graph yt divided by kp, then this kind of graph I will get. Okay. This last you can say value is called UVR, ultimate value of response. Right. As its name suggested, ultimate value. Which value? Response value. So it means that ultimately at what level my response wants to be there. Okay. Or you can say ultimately my response wants to achieve the value that is called my ultimate value of response. Okay. So here how I define the tau p, guys. So as I give you a very simple example yesterday, that let's suppose you have a 100-kilometer race. Okay, means you want to achieve the 100-kilometer milestone. That will be your UVR. Ultimately, you want to achieve the 100-kilometer. You want finish line. Yes or no? That will be your ultimate value of response. You started the race, and basically you at a particular time you reached at the you can say you covered the kilometer 63.2 kilometer, right? So that particular time, the time taken by you to achieve the 63.2 kilometer is your time constant, guys. Is your time constant. I hope that I am clear with you. Yes or no? Yes or no? Okay. So this is how the time constant defined yt reaches 63.2% of its UVR when time elapsed is equal to tau p. That is called my time constant. Yes or no? It is clear to you or not? Am I clear with this, guys? Am I clear with this? Okay. So tau p means that you are reaching the 63.2% of UVR. This is what you have to remember. Okay. If I'll you can say the second tau p, 2 tau p is defined in general process. It is defined. I'm taking this value from the literature, that when the process is achieving 86.2% of UVR. Right? Means something approximately this. This will be your 2 tau. This will be your tau. It is clear to you or not? Okay. And 3 tau p means that your process is achieving approximately 95% of the UVR. Okay. And 4 tau p is basically when your process is achieving 98% of the UVR. So from the literature says that approximately the first order system takes 3 to 4 times of tau p to achieve its UVR. to achieve its view here, right? And single tau p defined. How it is defined? That when the process is achieving its 63.2% of the U here. There is no need to remember these 2 tau p, 3 tau p and 4 tau p. There is no need to remember. Yeah, but you have to remember what is the tau p. What is the tau p? Now your question can be, you can ask a question, sir, what is the meaning of tau p? How this tau p will help us? If I know the tau p, about a process, okay, I know the process and I know the tau p of that process, I know the time constant of that process, then how this tau p will help me? Okay, again we will take a very simple example. Tell me guys that you guys are let me take an example guys. Let's suppose again this is my 100-kilometer track. Right? And this is our start line. And let's suppose me and Reddy are ready to cover this track, to cover this 100 kilometer, right? It is clear to you. So let's suppose this is a Reddy and this is me. This is me. Okay, our start line will be same. So we both started running. So this is the board of 63.2%. You can say it is 63.2 kilometer board. Reddy is here. Reddy is at this level, and I am here. I am here. Okay, so and this is the snapshot of a particular time. This is the snapshot of the particular time, guys. Right? Let's suppose it is. Let's suppose that the Reddy takes at this time. Basically, the time is about 1 hour. Let's suppose 1 hour. So in the 1 hour, Reddy is covered 63.2 kilometer, but I did not cover yet. Okay. In 1.5 hour, if I'll take the snapshot of the 1.5 hour, then what you can say that see that Reddy is here. Reddy is here, and now I am here. Now I am here. Now Reddy is here, and now I am here. After 1.5 hours. Okay. So guys, tell me what is the time constant for the Reddy, and what is the time constant for me? What is the time constant for Reddy, and what is the time constant for me? Can anybody tell me? पहले Reddy का लिखिए, फिर मेरा लिखिए. First value you have to write what will be the time constant for the Reddy and what the time constant for me. Please write it down. Please tell me guys. Four tau PM. Where it is 4 tau? No. Where is 4 tau? More than tau p. No. I think you guys are not getting my point. What I'm trying to say. What I am trying to say, you guys are not get that point actually. Reddy is greater than 1 hour, me is 1.5 hour. Yes, Vikita. Very good. See, guys, I think you are not getting my point. You are not hit to that particular point. A very simple point I told you, that at 1 hour ready position is at the 63.2 kilometer board and I am behind from the ready. So ready achieving its 63.2 percentage of its ultimate value, and the time taken by it is called its time constant. So the ready time constant will be 1 hour. Very simple, yaar. Wow, what is the hurdle in it? I don't know. This is the time constant for the ready, right? And after that, I told you that at 1.5 hour, ready is here, because ready is not basically waiting for me, na? Ready definitely will not wait for me. In the next half an hour, ready will be here, and I am here. So I achieved 63.2 kilometer, or you can say 63.2 percentage of my UVR. How much time I'll take? 1.5 hour. Then this is the time. Then this is the time constant for me. This is the time constant for me. What is the hurdle in it? So time constant for the ready is 1 hour. Time constant for me is 1.5 hour. Whose time constant is less? Ready time constant is less than me. Ready time constant is less than me. So it is so obvious that the one who achieve the 63.2 percentage of UVR first, for sure that system will achieve its UVR in the less time. Right? What I'm trying to say, just try to understand what I'm saying. I'm saying the one who achieve its 63.2 percentage of UVR first, that will cover the, or you can say that will cross the finish line first. That will cross the first finishing line first. In our case, ready will achieve in the 1 hour only 63.2 kilometer, but I am very far behind the ready. When I cross the 63.2 kilometer bar, ready already finished the race. So which one will be faster? In our case, ready will be faster. So if we have two systems and we know the time constant for both the two systems, if we have both the system, then we can we say that the system having the less time constant is faster as compared to the other system? As compared to the other system, yes or no? Like in our case, the time constant of the ready will be less. So I can say that ready will be faster as compared to me. In the similar way, if we have the two systems, system 1 and system 2, means this is the first order system and this is also first order system. I have the two systems. First, these two first order system I have. Its tau p is, let's suppose, tau p1 and its tau p is tau p2. If tau p1 is less than tau p2, what is the meaning? Meaning is that the system 1 basically takes less time to achieve its 63.2 percentage of the UVR. Then for sure it achieved its complete UVR, 100% UVR first. It means that my tau p1, it means the first system will be faster as compared to the second one. What is the meaning of fast system or sluggish system? Fast system means that that system, in comparison of other system, achieve its UVR first as compared to the other system. That's it. This is the meaning of the faster. Means it covers, or it finished the finish line. Am I clear with this? Yes or no? Am I clear with this? So tau p is a basically parameter that will give you the information about the fastness of the system. Right, fastness of the system or fastness of the process. Right, lesser tau p means process will be fast. process will be fast. What is the meaning of the process will be fast? That it achieve its UVR in less time. Please tell me if you have any hurdle, if you have any problem, right? So I'll use two terms. One term is let's suppose I have system 1 and I have system 2. It's tau p is tau p1, it's tau p is tau p2, and tau p is less than the tau p1. Then it means tau p1 is the faster as compared to the system 2, and system 2 is sluggish as compared to 1, right? So I'll use a term sluggish for the slower system. Please tell me if you have any problem regarding this, otherwise I'll move ahead. Tell me, guys. Okay. Now repeatedly I'm using a term ultimate value of response. Yeah, is as its name, it is very clear that what is this value. Mathematically, how we can calculate the ultimate value of response? Let's see this, guys, right? What is the meaning of ultimate value of response? Okay. Ultimate value of response. Ultimate value of response means ultimately what the system will achieve its you can say value, right? What is the value achieving by a system ultimately? Okay. Guys, whatever these definitions we are using, you will not find these definitions in anywhere in any book, right? This is that kind of definitions by which if I will read that line, I can quickly understand everything about a topic. Okay, that's why I write all these lines in a very simple language. Yeah, so ultimate value of response means the value, or you can say the value of response achieved by the system or process ultimately. What is the meaning of ultimately? Ultimately means that at t tends to infinity, finally what value will my system achieve? What is the value achieved by my system at t tends to infinity, or you can say at infinite time? That is my UVR, ultimate value of response. Okay, so what is my response for unit step? What is the UVR for the unit step? If I'll say, let's try to understand it. What is the UVR for step input? What is the response for the step input? It is my KKP into 1 minus e raised to power minus t divided by tau. Right? So if I want to calculate the value of yt ultimately, it means that at t tends to infinity, what is the value achieved by the system for the step input? So as it is it is in the t domain, so for the FPT, Apply FPT, that limit t tends to infinity. Yt is equal to AKP into 1 minus e raised to power t divided by tau p. If I'll put the limit t tends to infinity, then it will become 0. It will become 0. So what is the final value? It is my AKP. What is the final value, guys? AKP will be the final value. So what is this AKP? AKP is the ultimate value of response, guys, for the step input. Right? It is clear to you or not? It is my ultimate value of response. It is my ultimate value of response for step input. Means that if a system is disturbed with the system, first order. Okay. Let me clear this the silly mistakes which normally students, you can say, attempt. I know that you guys are understood everything, but still it's my duty to mention everything, right? Guys, please remember this, that this is the response of step input for first order. This is important. It's nothing like that Yt is equal to AKP into 1 minus e raised to power minus t divided by tau p is valid everywhere. Whatever the input, whatever the process, doesn't matter, and it is my constant value, it is my valid everywhere. No, it is basically calculated when the step input is disturbed the first order system. So this AKP is the ultimate value or response for the step input, right? And it is for the first order. Remember this, for the first order. Am I clear with this or not? Am I clear with this or not? Please tell me, guys. Please tell me that you can say that clear with this or not. Please tell me. Please tell me that I am clear with this. Yes or no? Where A is my magnitude of the disturbance and Kp will be my steady state gain. Okay. So if I draw this kind of diagram for this, then I can write this. This x is my t divided by tau p, and this x is my yt. Okay, this x is my yt. Okay, so what is the ultimate value of response? AKP. So this is my AKP, guys, right? This is my AKP. So AKP is the ultimate value of response, means ultimately at time t tends to infinity, my yt, the value of the yt will be AKP. So the response pattern is like this, as we know that. Let's see, you can say that t tends to infinity, it is like that. It is like that. It is achieved the AKP. It achieved the AKP, right? And at the time at which it achieved the 63.2% of the AKP, that corresponding time will be my out. Right, so this is your UVR. This is the ultimate value of response. This bending curve and this curve touch this value at a very huge time, at a very large time, defines that my system achieve its ultimate value of response after the t tends to infinity. Okay, and very simple that that if I'll write that what is the UVR of unit step input. UVR of unit step input. It is very simple. You have to put only one value. That is A equal to 1. Right? So UVR, what is it? KP. For unit step input, we know that magnitude will be 1. So it is 1, then it is KP. So KP is my what? It is my KP is my ultimate value of response of the step input. Yes or no? Yes or no? It is clear to you or not, guys? Please tell me. Now let's try to understand this. From this point, we try to understand the KP. So what is KP? KP is my steady state gain. KP is my steady state gain. Right? And what I found that what is the KP actually? KP is the ultimate value of response of the unit step. Yes or no? So how it defines it is the ultimate value of response of unit step input. It is my ultimate value of response of the unit step input. This is how mathematically KP is defined. Mathematically, this is how we can define the KP. Yes or no? It is clear or not? Now let's try to understand the significance of the KP. Like tau p is, what is the tau p? Mathematically, it is a 63.2% of UVR. But what is the significance? Significance is that it tells about the fastness of the system, guys. In the similar way, if you want to calculate the magnitude of the KP, then don't worry about that. Just calculate the UVR of the unit step input. You will find the magnitude in number value of the KP. Now we'll try to understand the significance of the KP. It means that if we have the KP value for a particular system, then what we can conclude about that system, guys. So I have the what is that? I have YT is equal to you can say that your AKP, right? This clear. So what is your A? A is the magnitude of the input. Yes or no? A is your magnitude of the input, and this is your change in the output. Change in the output, right? So basically, I can write this expression as change in output is equal to KP times change in input. Change in input. It is clear to you or not? Means the KP will decide that how this change in input will impact your change in output. Sir, we don't understand what I'm trying to say. Just take an example. Okay, let me take example of it and let's try to find out. Let's consider two cases. Case 1, and case 2. In the case 1, my Kp value is very large. Let's suppose it is my 1000. Okay, it is clear to you. And I'll make the change in the input is, makes the change in input is, let's suppose it is my 2 units. Okay, means that let's suppose initially that the value is going on the 100 and now it is 102. It is 102, right? 100 degrees Celsius and the change is only 2. It means it is now 102. What is the change in output? If you will calculate the change in output, then Kp, that is 1000, multiply with change in output, that is 2. The change in output will be 2000, guys. Can you imagine? Can you imagine what I'm saying? Let's suppose my output, initially my output is 200 degrees Celsius and my input is 100 degrees Celsius. If the Kp of the system will be 1000, then if input is only changed by the 2 unit, then your output will be 2200 degrees Celsius. From 200 to 2200 degrees Celsius. Can you imagine that by only 2 degrees Celsius change in the input, how you can see your output will change, by which magnitude? Yes or no? Okay. Let's take another example. Case 2. Let's take input change same 2. Okay, input change, let's suppose we are taking 2. Now my Kp will be 0.1. What is the change in output? Kp multiplied by input, that is only 0.2. Only 0.2 amount will change for your output. Means if your output is initially at the, you can say 200 degrees Celsius, now it is at the 198.8. Okay, it is clear to you or not? It is clear to you or not? Okay, sorry, 199.8. So can you understand what I'm trying to say about the steady state gain? Yes or no? Basically, the steady state gain, the Kp value will decide about the sensitivity of your system. How the output is sensitive towards the input. Okay, let's write all these things and tell me that it's clear to you now. Sir, but for unit step function, since the magnitude is unity, how does Kp account for this system? Change in output is equal to Kp. Change in output is equal to Kp. Where it is change? No. You are not getting my point. Ready? See. Just try to understand it. I think you want to say this as I conclude your doubt. You want to say this, sir. KPU calculate as UVR for unit step. And here you are writing yt is equal to AKP. Yes, I think you want to say this. Here you are you can say writing yt is equal to AKP, but I think sir it should be yt is equal to kp. Yes, ready? Tell me, is this your doubt? Is this your doubt? Okay, see. So don't confuse in this. Don't confuse in this. First of all, step multiple times I told you step input and unit step input both are the same. These are the same, guys. There is no, you can say, difference in the step and unit step. Unit step input is nothing but it is the step input step input itself. Step input itself, where step size is 1. In the unit step input, it is nothing but it is the step input itself here, and step size is 1 only. That's it. Okay. Kp is equal to UVR for the unit step input. This is the not definition of the Kp. Kp is equal to the UVR for the unit step input. This is not the definition of the Kp. This is the mathematical way to find out the value of the Kp. Just try to understand it. This is not the core definition of the Kp. Okay, this is not the definition of the Kp. This is the mathematics we can calculate that yt is equal to AKP. If my A will be 1, then yt is equal to Kp. This is how we can calculate my Kp. So this is the mathematical definition by which we can calculate the Kp, guys. This is not the definition. Right? Now, if I want to see the effect of the Kp, significance of the Kp, then I should be start with this now. Start with this. Kp is defined for everything. Kp is defined for every, you can say, every thing. It is defined for every you can say your input also. This is only the pure mathematics by which we can calculate the magnitude. So do not confuse in this. Yes or no? It is clear to you or not? When A is not equal to 1, when A is not equal to 1, then also Kp is there, ना? ऐसा थोड़ी है कि जहां पे A 1 नहीं होगा वहां पे Kp नहीं होगा. It is clear to you or not? Kp is always be there. Kp is always be there. Kp is not depend upon the A. Just try to understand it. To define the Kp is not dependent on the A. That if A equal to 1, then only I have the Kp. Then only the Kp will define. Kp is already defined for the transfer function, guys. Okay. If you remember this, if you go to the basic thing towards the Kp, then okay, the slide is you can say we don't have that slide. But if you remember that coefficient of the BFT, coefficient of the your FT will be the KP, right? This is kind of your differential equation. This ratio is basically, if the coefficient of the YT will be 1, then this ratio is basically your KP. So KP is not depend upon the A. If A equal to 1, then only KP will come. No. Yeah, if I have that A KP and I have that you can say magnitude wise, if I want to calculate the value of KP, then this will help me, and this is how we can calculate the value of the KP. Okay. But my base equation is this. So it means that if my KP value, by keeping input change same in both the cases, if my KP value will different, then the change in the output will be different, right? Here only here only by making change by 2 units in the input, it makes the change in the output as 2000 amount. Very huge amount. Means the 200 degrees Celsius output will reach up to the 2200 degrees Celsius. It means that my system is very, very sensitive. It means that my system is very, very sensitive. It means that my output is very, very sensitive towards the input. Right? Sensitive means a very small change make them very reactive. Reaction will be very huge. जैसे कि हमारा जब हम पढ़ते हैं तो हमारी क्लास में कोई ऐसा होता है कि वो बहुत सेंसिटिव होता है ना? We basically talked about that. Okay, he is very sensitive, or she is very sensitive. Stay away from him, or right, this person. Because if that person is sensitive, and if you will say anything, any very small anything, then reaction will be very high. You will get the very high reaction from them. And if I talk about the case 2, then if I'll talk about the case 2, then the 2 unit change only change will be 0.2, and even if you will say, even if you will take the change in input is 100, so we'll take the change in input is 100. My initial temperature will be 100, now my temperature will be 200. Then what will be the change in output? Change in output will be 100 multiplied by 0.1, it is 10. See, here only 2 units make the change 2000, and here the 100 units only change the 10 units. So here my output is less sensitive towards the input. So it means that steady state gain is basically giving the idea about the sensitivity of the system. Yes or no? It is clear to you, no? So it will tell about the sensitive towards the input. Right? It is basically, it is the sensitive parameter. And what about the tau p? Tau p is basically giving us the fastness of the system. So tau p is basically will tell you about the sensitivity of the system. And tau p will give you the idea about the fastness of the system. How my system is fast. Am I clear with this or not? Please tell me, guys. Am I clear with this or not? Please tell me. These two things should be clear. So how to calculate KP? Just calculate the YT for the unit step input. है Just take the final value, just apply the FPT, you can calculate the value of the KP. What is the significance of the KP? We already talked about it. Please guys, is it clear to you or not? Okay. Now, another response will be the impulse response. Please put the heading impulse response. So let's try to understand the impulse response, guys. What is the impulse response? Okay. That if my system is, you can say, if my system is disturbed with the, you can say, or impulse input, then what will be my output? How my output is basically looks like. Okay. So I know that my, okay, let me write this. It is my first order, and this is my input. This is my output. Okay, my input is, as you know that, it is my pulse input. T equal to 0, something like that. Now what will be my output? Okay. Okay, so what is the axis for the impulse? Axis value is equal to 1. And what is the transfer function for the first order? It is my Kp divided by 1 plus tau ps. What will be Ys for it? Ys is equal to Gs, that is a Kp divided by 1 plus tau ps multiplied by x, that is equal to 1. As you know that we need the response in t terms, then by taking Laplace inverse of Ys is equal to that Laplace inverse of Kp divided by 1 plus tau ps. Okay, do one thing, just divide the Kp in the both side, then what will we will get? Let's see. So Laplace inverse of Ys is nothing but it is my Yt, and it is equal to Laplace inverse of Kp over tau p divided by s plus 1 divided by tau. Kp divided by tau p is a constant term, so there is no need to do anything with that. You can take out from the Laplace inverse, then my Yt is equal to Kp my Yt is equal to Kp over tau p, and s plus something means e raised to power minus t divided by tau. So this is the response. This is the response for impulse. You should remember this also. This is also very important from the gate point of view. If you are okay with it, just let me know. Just let me know if you are okay with it. Okay. Is it clear to you? So what is my response, guys? My response is yt is equal to kp over tau p e raised to power minus t divided by tau p. Okay, so I can write it as tau p yt is equal to kp e raised to power minus t divided by tau p. If I'll if I'll draw the graph of it, then this is how we can draw the graph. Okay, that at x-axis it is my t divided by tau p, and it is my at y-axis my tau p by t. Kp is my ultimate value of response. Okay, so yeah, so it is my e raised to power minus x graph means that exponential decay you will get. Yeah, sorry, it is not ultimate value of response, it is the initial value of response. Okay, ultimately it is going towards the 0. So this kind of graph you will get. This kind of graph you will get. Okay, so if this input disturb this system, then this kind of response you will get. Okay. Okay, one important thing in this is, see guys, what is the unit step response? Unit step response is yt is equal to it is unit now, so it is my a will be 1 kp into 1 minus e raised to power minus t divided by tau. Let's differentiate this output dy t divided by dt. What you will get? This is my kp, yes or no? This is my kp, and it is my kp differentiation will be 0. It is my kp minus, and it is my e raised to power minus t divided by tau p, and it is divided by minus tau p. Minus minus cancel, means it is my kp divided by tau p into e raised to power minus t divided by tau p. Right, I think that this match with this expression, yes or no? And this is the response for the impulse. So can I say that I can say this, that differentiation of response of unit step input is equal to response of impulse. So as I already told you that impulse function is basically used as a mathematical aid instead of a practical problem. So if I'll have an idea about the unit impulse, if I'll have an idea about the impulse response, then from that I can calculate that what will happen if my unit step response will hit into that system. right? By just differentiating, or by just because these two responses are connected to each other. Okay, so let's take the discussion further in the next class. This is it from my side for the today's class. Okay, in the morning class we will take some 1 and 15 hours class, so that because in the evening slot maximum students join this class. So as I told you earlier that only you have to manage with the only for this week, or only for 2-3 classes. After that we will jump to after that I will schedule class in the evening batch. Okay guys, so let's resume our discussion from this point in the tomorrow's class. Okay, thank you so much. Let's meet in the next class. If you have any doubt, you can drop. Thank you so much. Bye bye and take care.